Okay, now I want to move along on the list and actually get into this idea of marginal significance. This is another gray zone for you. You'll notice it has E, marginal significance here. Look at that result for year one under emotion. So this is measuring after the program where you're better at controlling your emotions related to asthma. Notice the treatment effect there was kind of large, 0.75, easily above the 0.5. But notice what the result was there. It said a p-value of 0.07. It's close to being significant, but not quite. We actually would call this particular result marginally significant. This result is called marginally significant. If you get a p-value between 0.05 and 0.099, it's considered marginal significance. It's not considered statistically significant because it's not less than 0.05, but it's close. So you could say you have marginal significance there, meaning we think we have something here, but it's not quite statistically significant. Notice what happens when we double our sample size. It turns into completely statistically significant, as the case may be here. So that's just the difference between marginal significance and being statistically significant. Finally, table 3 I want to talk about a little bit. When I ran these studies, we actually gave people a quiz at the beginning and the end of the program, and we asked them questions like, asthma episodes cause bronchoconstriction. And of course, the answer to that is true. And we saw how many of these questions people got right at the beginning and how many questions people got right at the end. We predicted there should have been a significant improvement at the end of the program. There were 15 questions for the 20 people that were involved with this. So take a look at this table, and what I'd ask you to do with this table is kind of make a little key so you know what everything means here. So in the first column with this paired t-test, it's actually got the mean difference. So the mean difference actually stands for the difference between the pretest and the post-test. So in this particular case, if it says a mean difference of 8, you could probably surmise that people got an average of maybe 3 questions right at the pretest, although you don't see it here. And if they got 3 right at the pretest, that means they got 11 right at the post-test. That's exactly what we would want to have. That's an improvement of 8, and we would hope that that would denote significance. So we got the first column. The 8 is actually the numerator for the t-test. It's the numerator, and we want that number to be large. That shows the treatment effect. The next column, standard deviation, is just a measure of error. We want that number to be low. The third number, standard error of the mean, that ends up being the denominator for the paired t-test, or the within subject t-test. So when you put 8 as the treatment effect over 0.5, what do you get? Well, you get that t-score there of 16. DF, degrees of freedom, does anybody know why that's 19? Well, it's 19 because you have a total of 20 people in the study, so you take 1 away. So then, at the final level, we have significance. Notice it says 0, 0, 0. That's, of course, less than 0.05. I hope I told you the last time we chatted that if it ever says 0, 0, 0, you write p less than 0.001. So the way you would write this one out is a t, parentheses 19, equals 16, comma, p less than 0.001. And you'd say this is statistically significant, and it shows that the Tausman asthma program significantly improves knowledge after the intervention, which is exactly what we would want to say. The last thing that I have to share in this little tour de force, if you will, has to do with this idea of confidence intervals. A lot of people in statistics are not into this significance, no significance thing. That idea of the 0.05 thing, that really irritates some statisticians to say, well, if it's less than 0.05, that's significant, and if it's greater, it's not significant. And so it's kind of that all or none situation, and lots of times we have this gray, even that marginal significance. A way to deal with that, and something that people sometimes do, is they come up not with significance, but something called confidence intervals. So let me give you the real world situation here. If I asked you, before I ran this program another time, what would be your prediction in terms of running the same program and how much knowledge would be improved by? If I had to have you just make one guess, if I took 10 new people, ran them in the program before and after, and I said, what is your best guess for how much this program is going to help people? You would probably guess what? You'd probably guess 8. 8 would probably be your best guess. You would call that 8 a point estimate. And that would be very, very precise, your point estimate. You'd say, well, if I had to have one prediction, my point estimate would be, I think your program's going to help people know 8 points more after they're done. Now, you would have a lot of precision with that guess, with saying 8 points, but you wouldn't have a lot of confidence about it because, I mean, if it's even a little bit away from that, you would be wrong about your 8-point guess. So one thing that people often do is they form confidence intervals. That is a range of how much we think the program helps. And SPSS and other programs always give you a printout, and actually they compute a confidence interval for you. So if you look at it, it says 10 and 6 here. Your real world statement here would be the following. Nothing about significance, but your real world statement would say something like, you are 95% confident that the Tausman asthma program helps people between 6 and 10 points with knowledge. You are 95% confident that the Tausman asthma program will help people know between 6 and 10 points more after they're done as far as knowledge. Notice that now we don't have the precision. It's not just 8 points. Now we have not as much accuracy and precision. There's a range, but with that range we have more confidence. We have 95% confidence, and I don't need to show you how that is computed. So hopefully you've got these lessons down and this makes sense to you. Send me drafts, ask me questions, send me emails. I will expect when the test time comes that you will know this information. Thanks everyone. Bye-bye.